In our work with mathematics, we always want to try and undo something that we did, right? And so now let's, instead of using the derivatives to graph f, I'm wondering, what if we are presented with the derivative graph? Can we get the function from that graph, right? So we use bits of information about the derivative to assemble f, but what if we're given now a picture of f for which we have to draw that? Yeah, that's a little interesting question, but what we're being asked to do is find a function from its derivative, and that is an antiderivative. So if we're trying to go backwards and find the function from its derivative, that's when we're doing anti-differentiation. Now we'll learn more of the algebraic techniques next semester, but at least right now we can think about this at least from a graphical perspective, okay? When we are thinking about the notation too, just so we're aware, if we are given the graph of f of x, right, the antiderivative we always present as a capital F of x, just to differentiate the two, okay? So this notation here is saying that if we have the antiderivative, right, f is the antiderivative, and we differentiate that, then we get the original function f back, or the graph of the derivative, okay? So then the question remains, if we're given the graph of f, like we have an example, how do we get the graph of the antiderivative? Okay, so here is a function g, little g, and we want to sketch the antiderivative big G. If we know big G of 2 is, or negative 2 is 1. So, okay, well, that's a good starting place, right? So I do negative 2, negative 1. Okay, put my point there. Now, how do we generate this graph? So again, remember that the derivative is showing you the graph of the slopes. So I need to view g of x as the slope of g at x. Okay, so what this is telling me is that, for instance, at negative, when g is at x is equal to negative 2, it has a slope of 0, and then the slope is becoming more positive. It's approaching a slope of 1, so like just y equals x line, and then a slope of 2x, for instance, or slope of 2, and then the slope quickly changes, and then the slope is 0, and then it goes negative, and then returns to being 0. So I'm going to try to assemble that the best I can. Now this is just a sketch, so here's what I'm going to attempt. Okay, so I start here, and then slope of 0 increasing, slope of 1 right about there, and then slope of 2 right about there, or so. And then slope is still positive, right? But it's becoming less positive quickly. And then right here, it should have a slope of 0. So I'm going to make that flat. And then it should start to have a negative slope that's becoming quickly negative. So it's going down quickly. And then here it becomes a slope that is less quick, and then eventually at 0. I can maybe redo that last little bit. Something like that, perhaps. Okay, leveling out to 0. And I would say that this is the graph of g of x. So again, what I did is I viewed the green graph, little g of x, as the graph of the slopes. And then so you have to start with a point and then use that point as a launching off opportunity to get the rest of the graph.